And from forest from bare areas, you can still see the mean red edge band is quite powerful there in separating the two areas. If you use your NDVI, then you can still distinguish your forest from the roads. And NDVIs can also separate your forest from water. So this is the subset of the image, Sumbandla image, which I used in this particular case. So you can see the built-up areas within Tshwane Metropolitan, and the urban areas fall up very clearly. The water bodies are coming out very well. You can see almost your riparian areas along the river and some of the irrigated grasslands there. And the classification results using the Sumbandla set, I think the pinkish areas are the irrigated and riparian areas, and the red ones are showing you the roads. So I think effectively at a spatial resolution of about 6.25, I think this is quite good. And with the water bodies are coming out very well. The vegetation, you can easily distinguish between dense vegetation, which is the green, and the sparse grasslands, which is the light green areas. And the yellow areas are your bare areas. So the distinction there for a resolution of 2.5 and using only 3 spectral bands, I think it's quite great. So in terms of the accuracy assessment, we used a pan sharpened spot pan sharpened spot subset for that particular area, and I think as you can see, the accuracies for that very small area are quite elevated. So what we conclude from this, I think what we're seeing there is if you completely exploit the image, the spectral indices, your geometric properties, and your heraldic textual features, or any other textual measure, I think you improve your abilities of extracting imagery from Sumbandla's 3 spectral bands. And the next thing, obviously, from these results, we can still see that obviously the separability between buildings and bare soil is still very poor, but that can be improved using a digital surface model, of which that's the case for most of the satellite images which we use spectrally. It's too challenging to separate these two. And obviously the message is, I think, let's exploit this image. This imagery is there, so it's freely available. So we're looking for you to exploit that more, because I think that will allow us to even motivate further for future missions, South African, if we are to use the current images which we've got. And so, in addition, I think I should show you one classification which is for East London, where we didn't use object-oriented classification. We just used for pixel classification using minimum distance. One of the challenges Sumbandla said, they say the radiometry might not be very good, and minimum distance, I think, although it's not as highly sophisticated as, say, maximum likelihood, but it can cope with those issues which deal with the normality of the data and so forth. So in this particular case, we applied a minimum distance classification in East London to be able to see the urban boundaries and whether urban areas and built-up areas will be classified well. And the results, I think, they're relatively good. We're seeing the water bodies are being delineated effectively. We have got built-up areas. I think they're coming out properly, the vegetation and bare areas as well. So this is just some of the work we have done to demonstrate the value of Sumbandla set, and we encourage you to use this data. Thank you.